Okay, so from March 1997, as the planet rotates, we're able to see features that indicate the presence of frost, even. A frost cycle is going on Mars. So there is, to some extent, weather on Mars. There's, to some extent, seasons on Mars, and seasonal frost patterns, and even freeze-thaw cycles of different types. And we're learning a lot more about that these days because of orbital missions and of course, the rovers that we have on Mars now. So we're going to, as part of discussing Mars, we're going to talk about the possible presence of life there in the past, the possible presence of life there even currently, which hasn't been ruled out at the moment, and also the different ways that we're obtaining evidence that bear on those two questions. So we're talking comparative planetology. It's related to the origin of life questions, even on Earth, because if we can find one other example of a planetary body with life, it's sort of like infinitely more than just having one example, which is what we have now on the Earth. We just don't know how unique the Earth really is. There's just no way to know that because there's only one example. I mean, it's possible Earth is really unique in the whole universe. If a miracle really happened here, and that's why we have life on Earth, it's possible. Most scientists think that's not likely, but we can't rule it out because we don't have a single other example. So this is why we're so interested in the possibility of not only having life on Mars now, but even historical life, like this little critter here, which we now know could actually just be a fossilized cheese root. Actually, I'm making that up, but it sort of looks like that. It's apparently not evidence of fossilized life, but this is part of the debate that's been going on for the last decade or so regarding Mars. Okay, we've had lots of missions to Mars, lots of fantastic color photos. This particular one is one of my favorites because when you look out at this reddish desert, it actually kind of resembles the desert around Albuquerque, New Mexico. It's actually in that area, not when this came down, but when the earlier photos from Viking were relayed to Earth. And the impression we immediately got was this reddish colored desert. But this is really striking because it's so clear. I mean, it looks like you can just walk right out into this high definition television here and actually walk around there. So we're going to be talking about where these rocks came from. Are these rocks actually just native to that area on Mars, or do they indicate some kind of geologic process or erosion process? And there are mountains in the background and things like that. So we'll be talking about that. This is a shot from the little rover that came out from Pathfinder. So this is the sort of Pathfinder mothership, which is this guy right here, which shot that beautiful color image. And then we have the little rover, which had its own little black and white camera and was rolling around doing analysis. This is one of the older missions now. We've gone way beyond this level of technology. This is now about 15-year-old technology. But again, you get this impression of this quite sort of an accumulation of different kinds of rocks here. That little rover learned right away that these rocks probably were not all formed together. It actually landed in an area where what we were seeing was almost like a geology museum of Mars. A lot of rocks that didn't form together but somehow got accumulated in that area by a process that we now think we understand was actually related to a huge flooding event billions of years ago that swept water from the southern hemisphere of Mars, which generally has a higher elevation than the northern hemisphere. So we think what happened was that historically during an early period of volcanic activity, water ice, which froze out of the atmosphere because of Mars' large distance from the sun, that water ice, which was deposited in these highlands in the southern hemisphere, melted and created a precipitous, huge flood with all kinds of crazy waterfalls and river systems into the lowlands in the northern hemisphere. And if you look at the landing sites here, we're talking about the first landers, Viking 1 right there, Viking 2. They tended to land either in the northern hemisphere or near the interface between the northern hemisphere and the southern hemisphere, which turns out to be a great spot to land because you see the direct evidence of this massive flood I was talking about. That's actually what accumulated all those different types of rocks in the area. And by the way, I mentioned a couple of volcanoes before. These are the volcanoes that we were looking at before on that global image of Mars. This Olympus Mons is actually the largest volcano in the solar system, but has been extinct for hundreds of millions of years. There's no current volcanic activity on Mars right now. Okay, so there's a couple of different panels I'm going to show you. This one here mainly emphasizes the Viking missions, and those landed on Mars in the mid-1970s. And Pathfinder, which was around 15 years ago or so. But we've had missions since then, too. Of course, the Spirit and Opportunity rovers are well-known rovers. Those are the previous generation of rovers, not the current one, but they're relatively recent, within about 10 years. And those rovers you see landed here, Opportunity and Spirit over here, again in that interface between the northern and southern hemispheres on Mars. And we've had more landers. We now have a few more that we can talk about. One is Phoenix. This is very interesting because it landed actually inside the northern polar region where we believe water ice is located. Now, the distance that Mars is from the sun, you actually can have dry ice. You can have frozen carbon dioxide. But you can also have water ice. And until Phoenix landed there, we really didn't know how much of each type of ice was there. But it turns out there's a lot of water ice, good old frozen H2O, at the polar regions of Mars. And that's one of the areas where this water from the early primordial atmosphere apparently is stored right now. Okay, but it's not just Phoenix. We also, just to review this, we have the Vikings there, Viking 1, Viking 2, Opportunity rover there, Spirit rover there. But this is the current big enchilada, or burrito maximum. Oh, that's another little expansion there. The big enchilada, burrito maximum. Don't just quote me on that. Curiosity. That's the most capable mission that we've actually ever sent to Mars. It's got the most sophisticated science laboratory. It's actually the size of a Prius, basically, rolling around still on Mars right now, doing all kinds of interesting stuff. And again, you see that even Curiosity landed in this zone where we can study the interface between the northern and southern regions. Okay, so the Phoenix mission, which is the one that I mentioned landed in the North Polar area, this one was specifically sent to study icy compositions on Mars. And I just want to show one quote that I found. So not only did they find water ice, this is the chief principal investigator from the University of Arizona, not only did they find water ice, which they did expect, but they actually find that the site was warmer and wetter than it is right now in the recent past, as recently as a few million years ago. Now that doesn't sound that recent, but you got to realize by geological scales, a few million years ago is actually a very small amount of time. So we're looking at evidence for a warmer, wetter polar region on Mars. Now, obviously, the polar region is the coldest region on Mars. So if you see evidence in the polar region that it was warmer and wetter, it really implies that the entire planet was warmer and wetter and probably had an extensive ocean system. All right, so when we look at topography of Mars, we see evidence for all kinds of interesting things going on. Not really tectonic activity these days, but other types of activity. Certainly there's plenty of evidence for landslides and ground motions of this type, forming canyon systems. But there's also a lot of evidence for flowing water. For example, a lot of the canyon features that we're seeing here were principally done by flowing water during a period of time when Mars experienced this huge flood that I was talking about. Yes? Now, we haven't really landed rovers in the southern hemisphere. I'm thinking the reason for that, I mean, we do have a unmanned mission that's very early one from 1970s. I'm thinking the reason for that probably is kind of the same reason that they landed in the Mare on the moon. They wanted to basically land in regions where it's going to be a little smoother, you know? Because it turned out to be very, very challenging to land on Mars. The United States of America has a pretty good track record. More than 50% of our missions have succeeded. But we've had amazing failures as well. Like we had, I think the global surveyor, that was what it was called, actually just slammed right into Mars. You know? And the reason was because they had two labs involved, and literally what happened was one was using the metric system, and one was using the good old English system, and their computer programs were just passing numbers to each other, and numbers don't have units. So one team thought they were talking about kilometers the whole time, the other thought they were talking about miles, and they literally miscalculated the orbit and just, you know, slammed a $100 million satellite after all that right into Mars. And other nations have had even worse luck than we had. So I'm thinking that because of the general challenges of landing on Mars, they probably have tended to want to stay in the northern hemisphere, just, again, just to increase the odds of success there. But it would be absolutely fascinating to go into the southern hemisphere when we're able to do that. Okay, so anyway, back to this. There's the evidence for water having created this kind of feature, but then there's also evidence for impact. That's certainly an impact crater right there. There's no way that's a volcanic crater. That's an impact crater which actually probably got eroded away on the side by subsequent water action. And again, lots of evidence for historical massive water flows, like these little islands, which were created, and what you see here is water flow from south to north, so north to south. And this crater apparently pre-existed the flood, and the crater wall was raised up enough to kind of preserve the interior of the crater against this flood, so you get this islet formation behind it. Oh, and then there's, of course, the famous face on Mars. I don't know how many of you have ever seen a face on Mars before? Yeah, well, we now know that this is just an imaginary thing. It's not really anything significant, and we don't really, and when you zoom in on this thing, it doesn't really, oh, then there's also this. Forgot about this. Now, the new thing, actually, now that we've zoomed in on the face, and we realize that it's just you zoom in, it doesn't really look like a face anymore. But that's now been supplanted by, of course, Bigfoot on Mars. Latest thing. We don't really think there's literally a Bigfoot running around on Mars, but it's one of these situations where when you have 1 million images of Mars, which we have now, 1 million of these high-resolution images, you could look in there and find just about anything you want to find. You've got the imagination, so it makes for lots of interesting headlines on National Enquirer and whatnot. But and NASA's all for finding life on Mars. I mean, if there really was a Bigfoot running around on Mars, I personally believe NASA would not keep that hidden. They'd get pretty excited about that, because just think of what it would do for the NASA budget. We'd be sending all kinds of spacecraft to Mars, right? So that they wouldn't keep that hidden. That would actually be big news. So I'm not one of these people who buy into any sort of conspiracy theories about that. All right, so actually this is just another example where we're seeing sort of something that looks very much like a river system on Earth, the serpentine motion, the typical serpentine motion of channels that are cut by water. No water in there right now, but again, evidence for historical massive flows.